Welcome to Sundar's lecture, and you see this is lecture number 26. What are the topics we have seen in the last class? See, we have started with the star delta connection and we have drawn the symbols with resistors, and we started writing the expression for RAB, RAB, then RAC, then RBC for both the star and delta connections, right? So we have taken this as expression 1, 2, 3, and then what we have done, we have added all the expressions to get a final expression, that is expression number 4, and uh, then we have subtracted the expression number 4 with 1, 2 and 3 to get RA, RB and RC. See, the ultimate aim is to get what is RA in terms of R1, R2, R3. That means RB in terms of R1, R2, R3 and RC in terms of R1, R2, R3. That is what we have got in expression number 5, 6, 7. Which means, see, if they have given you a delta connection, if they have given you delta connection, that means with R1, R2, R3, what is the equivalent star connection? How can you find the equivalent star connection? See, RA is equal to this expression R1, R2 divided by R1 plus R2 plus R3, right? So if you put all these values in this expression, you will get this resistor value. And RB, you put R2, R3 and R1 plus R2 plus R3, then you will get RB. This value of resistor you will get by this expression, right? So this 3 expression means to us for delta to star connection. If they have given you delta, then you can easily get the star connected value like that, right? So fine. Now what we will do, we will get the R1, R2, R3 in terms of RA, RB, RC. That's all. That is our ultimate, that is our next aim. That is our next aim. See, we have taken the expression 5, 6 and 7. First of all, I will do certain things, but you don't know why I am doing that, but then you can understand why I have divided RA, RB, RB, RC and RC, RA. Let us we do that. So first what we do, first of all, what we do now, we try to divide RA on, we try to divide RA by RB. See, I will divide this. If you divide RA by RB, then these two R1 plus R2 plus R3, R1 plus R2 plus R3 both are same, right? So they will get cancel each other. That you know. I don't need to write here, you know. So what we will get here, only numerator and denominator will be divided. So you will get R1 plus R2, sorry, not plus, R1, R2 divided by R2, R3. Here you see what we can do, we can cancel this R2, R2. So finally we will get, finally we will get RA is equal to R1 by R3 is there, R1 by R3 is there, then RB can be brought to the right hand side, right? So RB into R1 by R3, like that you can write. Anyhow you can change this expression, right? Anyhow we will write like this itself. So anyhow, so what we will do, we will just write like this, RA by RB, that should be equal to R1 by R3, like this. So this is expression number 8, right? So next what we will do, we try to divide RB by RC. So you see RB by RC, we try to divide this, we try to divide RB by RC. So if you divide RB by RC, what you will get, these two will be cancelled out, R2, R3 divided by R3, R1. So R3, R3 will be cancelled out, remaining things will be R2 by R1. So you will get R2 by R1. So write it as expression number 9. Like that, what we will do now, we try to divide RC by RA. RC by RA. So if you divide RC by RA, see R1, R2, R3 will be cancelled out. RC by RA, so R3, R1 divided by R1, R2, right? So R1, R1 will be cancelled out. So remaining things will be R3 by R2. So R3 by R2. So this is expression number 10, right? So this is what we have done. So now what I will do, my aim is to get what is our ultimate aim. Tell me what our ultimate aim here. I need to find what is R1 in terms of only RA, RB, RC. In terms of only RA, RB, RC. So that is my ultimate aim, right? So for that, what I will do now, I will take this expression, RA expression, right? I will take RA expression. So from expression number 5, so I will take, see, so from expression number 5, I will take RA, which is equal to, that is expression R1, R2 divided by R1 plus R2 plus R3. So this is the expression number 5. So I have taken from expression number 5. Then what I will do, I try to substitute the values. Say I try to substitute the values. See, I will keep this R1 as it is, and I have RA is already here because I need R1 in terms of RA, RB, RC. So I will keep R1 as it is, but instead of R2, R3, I have to substitute some values. Then what is those values? I will tell you, right? See RA, I will keep RA as it is. I don't have any problem. Since R1 I need to find, so I will keep R1. And instead of R2, see, we have many expressions. Instead of this R2, what you can do, you can substitute, you take this R2, then what you will get, R2 will be is equal to R1 into RB by RC, right? From expression number 9, I am just substituting here. So what is that? That should be into R1 into RB by RC, right? So like this I will get. So this will be divided by, then R1 is there, this R1 you keep this R1 as it is, you don't do anything with R1 since we need to find R1, plus what is R2? R2 again we can substitute the same expression, right? Instead of R2, what we can write, R1 RB by RC, like this, right? So plus, then I have R3. So instead of R3, what you can do now, you can substitute, instead of R3, you just bring this R3 to other side, and if you bring this RA by RB to this side, so what you will get? R3 will be equal to R1 into RB by RA. So R1 into RB by RA, right? So this I have substituted from 8-9 expression to the RA expression. So if you take, if you simplify this expression, so how can we simplify this expression? See, RA is equal to, so in the above side, in the numerator, it is R square, R1 square into RB by RC. So in the denominator, you see what we can do in the denominator, you take R1 commonly outside. This is R1, this is R1, this is R1. So what we can do here, we can obviously take R1 commonly outside. So what I will get, 1 plus RB by RC plus RB by RA, right? Like this. So now what we can do here, obviously we can cancel this R1 with this R1, right? So if you take LCM and simplify this, so RA will be equal to, you see in the numerator you keep as it is, R1 into RB by RC, there is no issue with this, all divided by, you take LCM for this term, what you will get, a whole divided by, see, 1 minute, what we will do now, we will keep this R1 RB in the above side in the numerator, then we will bring this RC to the denominator. That will be very easy, and that will give you much more clarity. So this R1 RB you keep as it is, and you bring this RC to the denominator side. So what you will get? So this will be RC plus RB RC divided by RC plus RB RC divided by RA, right? So what we can do here? We can easily cancel these two expressions. So we will get RA is equal to R1 RB whole divided by RC plus RB plus RB RC divided by RE. So now what we can do here? It is very simple, right? What we can do? We can take LCM, right? LCM, and then we will get the value. See what we can do. We just keep this R1 one side because we need R1, right? So you bring all these terms to the other side. So what I am doing, I am just keeping R1 to the one side, and already there is RA. So RA will be there. Then this numerator will go to this denominator will go to the other side numerator. So this will be RC plus RB plus RB RC divided by RA divided by all divided by this will be RB, right? So now you further simplify this. What you will get? R1 is equal to, you just multiply with this terms. So what you will get? RA RC plus RA RB plus, you see, if we bring this RA to here, this RA and this RA will be cancelled out, right? This RA and this RA will be cancelled out. Other terms will be RB RC, that we will keep RB RC divided by RB. So this is the final expression. You see, I will write here anyhow. I will write this one again, so that we can easily understand. So you see, R1 is equal to, I will just rearrange this sentence, rearrange these terms, so that by seeing itself you can write down these expressions. RA RB plus RB RC plus RC RA whole divided by RB. Right? This is the final expression. So I will write this expression number 11. Right? This is expression number 11. You see, I have done this one. I have done this to get what is R1. Like this, what you do by yourself to get R2, R3 expressions by going for expression number 6, like this. In the expression number 6, you keep R2 only. You don't do anything with R2, but instead of R3, R1 and R3, you substitute with these values, and you finally find what is R2. Right? And like that, you go for RC expression number 7. You do you just keep R3 as it is, and you substitute R1, R2 with these 8, 9, 10 expressions to get what is the value of R3. Right? Like that, you substitute and you find the values. I will write down the final expressions here. So I will write similarly. So R2 will be equal to RA RB plus RB RC plus RC RA whole divided by, you will get for R2 it will be RC, then R3 will be equal to, so this is the expression number 12, this is the expression number 13. Now you see, I will tell you one thing, just one thing. You see these expressions, it is very easy to remember. So in the numerator, you will get RARB plus RBRC plus RCRA. In every numerators, you will get the same things. This is for R1, R2, R3 expressions, right? So, okay. See what I have told you. This R1, R2, R3, every expression have what is the numerator? Numerator is same, RERB plus RBRC plus RCRB, right? In the denominator, how will you know this denominator? You come here, I will explain you this term. What is the thing you need to find? You need to find what is R1, right? What is R1? So you have to find what is R1, this term, this R1. If you want to find what is R1, which means which is connected between A and the C point, A and the C point, right? A and C point, which is the opposite resistor here, RB. Try to understand what I am telling, right? You need to find what is R1. R1 is connected between these 2 points here in the delta connection, right? You compare with this one. This is connected between these 2 points, and what is the opposite resistor here? That is RB, right? So that will come in the denominator part, right? This numerator part you can easily remember. RERB plus RBRC plus RCRE. You don't need to mug up the formulas. That is what I am telling this one, particularly how to remember these kind of formulas. Then you see R2, where is R2 is connected? See, R2 is connected between point A and point B. Point A and point B, which is the opposite resistor, that is RC, right? That should be in the denominator. That should be in the denominator. As well as RC, R3, you come here. R3 is connected between CB, and you see CB. What is the opposite resistor? RB, RA, and you write the expression RERB plus this numerator term, and then you divide it by the opposite resistor, that is RA. Very simple, right? Like that, you see RA, RB, RC expressions where denominator parts will be same. Here, numerator parts would have been same in all expressions. Like that, in RA, RB, RC expressions, your denominator parts will be same. See, if you take RA, you see RA, RB, RC, like that R1, R2, R3, right? Like that, if you see RA here, then you put first R1. What is the next to that? That is R2 divided by R1 plus R2, R3, that is common. You come to this expression now. You see it is RB. RB means what? You can write R2. R2, and then what is the next term? R3 divided by R1 plus R2 plus R3. And you come here RC. What is the RC? In delta connection it is R3, right? Which means third term. R3, what is the next term? Next term means you have to go for R1 again. R3, R1 divided by R1 plus R2 plus R3. See, writing the expressions, since you have to mug up these expressions in examination point of view, I am telling, or for any GATE exam, for any competitive exams, you need to remember these formulas, because these terms, the star to delta connection as well as vice versa, delta to star connections will be needed to solve some problems or to get some what to say, to get some inbuilt problems, right? Like you would have you are solving a different problem. There you need to find what is the star and delta connection to simplify the problem easily. So you need to remember these formulas. That is not necessary. You go for the shortcut method and you will get the better idea to remember these formulas, right? So we will take an example problem in the next class. Then we can solve that problem so that you can easily understand whatever the topic we have taken till now, we would have gone for example problems. Like that, we will take an example problem in the next class, and that will be very simple, because you know the expressions now, that you just need to substitute in the expression, that's all, right? So you go through these expressions, we will get to the next class, right? Thank you.